One of the ways in which we can perform the calculations for learning curves is using a learning curve table. So a learning curve table follows a set format or pattern with which it performs the calculations. In that format, we have a column for units or batches depending on what we're dealing with, right? So we might be producing individual units or we might be producing batches of units. And remember, if we're producing one batch of 10 units, that means we're not learning 10 times, we're just learning one time, as opposed to producing 10 units one after another, right? So we have a column for units or batches. Then we have a column for the average time or cost per unit or batch, depending on what we're going for. We have a column for total time across the units, or sometimes called cumulative time. And we have a column for incremental time, meaning the additional time taken by the additional units produced, okay? Incremental time, sorry. Yep, let's just erase that. So incremental time. Now, the units or batches column follows a standard format, always, okay? And that is, you start with 1, and every time you move down a row, you multiply the previous value by 2. So 1 into 2, 2, 2 into 2, 4, 4 into 2, 8, and if we had to continue, we would have 16, 32, 64, and so on. Why by 2? Because remember, the premise of learning curve was that we're considering things if the output doubles. So hence we're doubling the previous number of units. Okay? Now, usually we'll be given a time for the first unit. We take a starting point. Let's represent that time with A. Okay, the time for the first unit. And every time we move down a row, we multiply the previous average time per unit by the learning rate, which we'll represent with R. So if 1 takes A average time per unit, 2 will take AR. If we move down a row, we'll multiply the previous value by R. So AR into R will become AR squared. Once again, if we move down to the next row, AR squared into R will become AR cubed, and we continue moving down, right? That's just a standard pattern for the learning curve table. As for the total time, well, we have the number of units and we have the average time per unit. The total time is simply multiplying the number of units with the average time per unit. So we simply multiply all of these values together to fill out our total time column. So 1 into A becomes A, 2 into AR becomes 2AR, 4 into AR squared becomes 4AR squared, and 8 into AR cubed becomes 8AR cubed, okay? As for incremental time, we'll just show how that calculation is done based on the actual numbers once we fill this out. But this standard format of formulas is very useful to know, because what you can do then is simply find the values for A and R, plug them in, and you have your complete learning curve table. Let's apply this concept. So let's say A, the time for the first unit was 100 hours. The first unit took 100 hours to make. And the learning rate R was 80%. So let's fill out a table based on that. So we have our units, average time, total time. So let's fill them out based on the formulas above. Remember, units will still have the same format always, 1, 2, 4, 8. Average time for the first unit was 100 hours. Okay. Every time we move down, we multiply the previous value by R. So 100 into 80% gives us 80. Moving down, 80 into 80% gives us 64. Moving down, 64 into 80% gives us 51.2. And for total time, we multiply the units with the average time. So in each of these cases. Okay, so 1 into 100 becomes 100. 2 into 80 becomes 160. 4 into 64 becomes 256. 8 into 51.2, you can use your calculator, it should be 409.6, okay? And now we can also show how to fill out the incremental time column, right? So incremental time, we simply take the total time of the row and subtract from it the total time of the previous row. In the first row, this doesn't apply because it's the first row, so the incremental time will simply be 100. The unit took 100 hours to make. In the next row, the total time was 160. From 160, we subtract 100 to get 60. For the next row, 256, we subtract from that 160 to get 96. And in the last row, 409.6 minus 256, we get 153.6. Okay, and we can carry on with this format if need be. So this is what the table is. But what's the interpretation of this table? So this is how the table works. What we're saying here is that the first unit we produced took an average time of 100 hours, meaning the total time was 100, right? So the first unit we produced took a time of 100 hours to produce, okay? Then the first two units we produced, this includes the first unit, took an average time of 80 hours per unit or a total time of 160, meaning that the next unit we produced to double the output took 60 hours incremental time. So the first two units, first unit took 100, second unit took 60, on average of 80, total time 160, okay? Then 4, we doubled the output again, the next two units that we produced. The next two units that we produced, so there's two units here. When we produced those, the first 4 units, including these first two, took an average time of 64. The total time taken was 256. So this was 160. And the next two units took 96 hours, meaning this was 96, for a total of 256 for the first 4 units. Likewise, if we carry on to double the output from 4 to 8, now we have the next set of 4 units, right? So these are 4 units. And these 4 units took a collective of 153.6 hours to produce, right? If we lump that together with the first 4 units, which took 256 hours, we took a total time of 409.6 to produce the first 8 units at an average of 51.2 per unit. So that's what this table looks like, okay? And we can use that for calculation purposes. So for example, if we didn't want to fill out the entire table, we could simply look at the formulas up here. So let's say we wanted to find out directly how much was the total time for the first 4 units, right? The first 4 units total time formula is 4ar squared. So 4a is 100 into r squared 0.8 squared. And this would give us 256, which we have down here, okay? Now, just for practice, let's do the same for a different learning rate. This time, let's say A is for 100 hours, again, but the learning rate now is 90%, okay? So, we once again have our columns, units, average time, total time, and incremental time, right? And units once again follow the pattern 1, 2, 4, 8. Average time. So the first unit took 100 hours, so 100 here, and if we multiply these together, 100 here and 100 here as well, right? Average time, every time we move down a row, we multiply by the learning rate. So 100 into 90% gives us how much? 90. So that's the average time the first 2 units took, meaning they took a total time of 180. And for incremental time, 180 minus 100, the second unit took 80 hours, while the first unit took 100 hours. Once again, for average time, when we move down, we multiply the previous value by 90. So 90% into 90 gives us 81. 4 into 81, meaning the first 4 units took 324 hours to make. 324 minus 180 will give us how much? It should give us 144, meaning the first 2 units took 180 hours to make, the next 2 units took 144 hours to make, for the total of the 4 units to take 324 hours. Finally, 81 into 90%, you can use a calculator, we should end up with 72.9. Multiply that by 8, we get a total time of 583.2, and incremental time 583.2 minus 324, 259.2, meaning the first 4 units took us 324 hours, the next 4 units took us 259.2 hours. So the first 8 units took us a total of 583.2 hours. Okay. Now, what are some of the takeaways we can have from these tables? First of all, notice the average time. It continuously is going down because we're learning and reproducing things at a faster rate, right? The total time obviously is increasing because we're including the time for the previous unit as for the next units as well, right? But more importantly than that, let's compare the two tables with the different learning rates, 80% versus 90%. So the first 8 units took 409.6 hours if the learning rate was 80%. If the learning rate was 90%, those same 8 units took 583.2 hours to make. So which learning rate is better? Well, clearly 409.6 is much lower than 583.2. So under 80%, we took much less time than we did in under 90%. And that's the thing. A lower learning rate is better. So these tables are great. We can use the formulas, the base table formulas we covered up above, to pretty much do any calculation fitting these patterns. But that's the problem with this table as well. Patterns 1, 2, 4, 8, etc. right? What if we need to do a calculation for 3 units, 5 units, 6, 7 units, right? We can't use the table for that purpose. Instead, then we have to use the learning curve formula, which we'll cover in an upcoming video.